Technologies that will change the world. Welcome to Fan Screens, and here are the most incredible emerging technologies that will change the world. Spin launch. There's been a lot of focus in recent years on private space companies and their quest to develop vehicles that can take paying customers into orbit. But the reality is that, especially with the pollution that traditional space flight creates, these advances won't make a difference to people other than billionaires for quite some time. There is, however, a lesser-known company that's making huge strides in making space technologies far cheaper, greener, and easier to access. It's just that their focus is on the satellites and not on human travel, known as spin launch. The concept is actually rather simple, although it is, of course, extremely complicated to put into practice. Founded in 2014 and funded by large companies such as Airbus and Google, they are building a kinetic energy launch system to insert satellites into orbits instead of relying on chemical rockets. To do this, they have designed a vacuum-sealed centrifuge and that will spin objects around before releasing them into the space and speeds up to 5,000 miles per hour. And once they reach a suborbital height, a traditional rocket booster can take over. This concept significantly reduces the amount of fuel that needs to be burnt and make it even better. All of the energy used of this power to the centrifuge is derived from green sources such as solar and wind. The company has even proved that most traditional satellite components are able to withstand the 10,000 Gs that'll they'll subjected to during the launch, and even projects that it will cost less than $500,000 to send one into space, as opposed to the tens of millions it currently does with the test version, always built and conducting launches. They hope the full-size device will be ready within a few years. This could permanently revolutionize satellite launches. Graphene. Industry is continually looking for new materials to offer stronger and more reliable performance. But the next game-changing development is expected to be graphene. It's a substance that's long been theorized to exist but has proven to be so complicated to manufacture that it's taking until now to become feasible. As the name would suggest, it is derived from graphite, which is the material. You'll be familiar with that used in pencils. Made entirely from carbon atoms, graphite is a three-dimensional structure. But the exciting thing about graphene is that it's two-dimensional. What this means is that the carbon is arranged perfectly in a hexagonal honeycomb formation that's only 0.3 nanometers thick, and there's just 0.1 nanometers between each of the atoms. In practice, this new arrangement offers huge benefits that are only just starting to be fully understood. Graphene can conduct electricity far more efficiently than copper, for example. It's also used 200 times stronger than a steel but 6 times lighter. It's almost completely transparent because it only absorbs 2% of light, and it's impermeable to gas, even the lightest ones, and it can also have chemical components added to the surface to alter its properties. Researchers see graphene more as a platform that developers will be able to arrange in a way that plays to their needs. It could, for example, revolutionize touchscreen technologies to be incorporated to make lighter composite materials, and has a number of uses and electronics too. The possibilities are truly endless, and it's expected to be possible to produce it in the commercial quantities within the next decade. GPS-3. First beginning in 1973 and completed in 1993, the American GPS satellite network was the first global navigation system and revolutionized the way that everyone determines where they are on Earth. At first, the benefits were envisaged for the military, but technology has now had an impact on all of our lives, from the way certain electronics work to stat-nav systems and location-based tracking. The problem with GPS, though, is that the original 24 satellites, along with the further ones that were subsequently added, don't provide a perfect resolution and are only accurate within a few feet. They also don't provide full coverage around the world, as anyone who has tried to use location tracking in mountainous areas or dense urban environments will know, and the signal are actually relatively simple to block, which is a contrast threat for military use. There is therefore therefore huge demands for improving the system, and the technology has already been developed to do this, as known as the GPS-3, and built by Lockheed Martin. The satellites are already being launched and are as expected to have fully upgraded the network within a few years. When the project is complete, the signals will by far more precise and then now 8 times stronger, so they can't be blocked, resulting in improved safety, signal integrity, and far greater accuracy. Floating farms. As the world's population continues to grow, one of the biggest problems we face right now is how to produce enough food to satisfy everyone's needs. Amazingly, an estimated 30% of the global land surface is dedicated to agriculture, and a third of that is used from crops, and remaining 2/3 is used for grazing livestock. And this does not only restricts the potential areas in inhibition, but also encourages large-scale deforestation and habitat change to create more farmland. Some companies are looking for alternatives to this, and you may have heard of vertical farms that look to improve the yield for the same size plot of land. Others are looking at far more radical solutions. One is the idea of floating farms, which can involve building huge complexes that sit on the surface of the ocean, can be moved to where they're needed, and crucially are temporary. They make use of areas that wouldn't be used for anything else and turn it into a profitable commodity. Incredibly, one of these has already been in operation for several years in Port of Rotterdam in the Netherlands, where a company called Belladon has built a floating platform designed to farm 40 Meuse Rhine-Isle cows that are all milked by robots, by producing the product as close to the end consumers as possible. They are reducing transport costs too. They also plan to be able to install floating farms in regions that have suffered from disasters to get food production up and running far quicker than would otherwise be possible. Edge computing. The way we use computers has changed significantly in the past few years, decades, and so has the way of technology is designed to give us the best service. At first, everything was done on a singular device in our homes, and now we mainly use cloud computing, whereby most activities from our emails to documents and virtually everything else is held online. And our devices are essentially windows that grant us access to this. The problem with cloud computing, however, is that most companies rely on the infrastructure or just a few cloud providers. Amazon, Microsoft, Google, and IBM, with Amazon alone accounting to 47% of the market. Quite simple, everything that can move onto the cloud has pretty much been done so already, and there's a very little room to grow in that space. So others have been looking at the so-called edge of the cloud. What this really means is that they're exploring ways to bring the processing and storage of the cloud geographically closer to where the user is, in order to improve the experience rather than just relying on a few data centers. It will see more work done locally, and the idea is that this will significantly reduce latency, will also improve privacy and security, and will help reduce the bandwidth being used so the infrastructure doesn't buckle under the pressure of increased usage. In many ways, it may seem as if it's going back on the idea of cloud computing, but it's really harnessing it to fuller effect. If fingerprint or facial authorization is dealt with directly by your smartphone, rather than waiting for a server to reply, you'll be able to access your online content much easier. Similarly, self-driving cars are currently the best example of edge computing. Rather than waiting for the server's response, it can function independently, but at the same time needs to be centrally controlled so that it's automatically updated and so the algorithms can be improved. Self-healing concrete. Concrete is one of the most important construction materials that's used around the world and is second to water in terms of the most consumed material. Amazingly, twice as much concrete is used in construction than everything else combined. This works out to be the equivalent of more than 3 tons per person in the world each year. The problem is that even though it's a tough and durable material, it's susceptible to wear and tear and can develop rot sprockets and cracks and holes that affects its stability. In the long term, this means that it either needs to be maintained or replaced to avoid disaster, which can be a costly endeavor. But researchers have come with a new solution: self-healing concrete. By adding bacterial spores to the concrete mixed along with a food source like yeast extract, an amazing thing happens. When the concrete cracks, the bacteria are exposed to oxygen and water and begin to consume the food and multiply, and then produce calcium carbonate or limestone as byproduct. This in turn seals the cracks and if done right, means that you won't even able to see where the crack has formed into the first place. For small openings, the process can be completed within around 14 days, and it'll prevent them from widening and becoming a greater problem. Soon, it's expected that virtually all concrete will incorporate technology like this, and days of potentially dangerous faults will be over. Hydrogen fuel cells. The automotive industry is going through its biggest change in living memory, with virtually every manufacturer trying to develop their own technologies to reduce the reliance on fossil fuels. And while electric and battery concepts seem to be the way forwards, they certainly aren't a magic bullet. There are concerns surrounding the provision of green electricity to all that it needs, and the fact that our electrical grids simply aren't designed to handle the loads that will be required. Even if this was sorted, there's also the fact that batteries are relatively very heavy for the amount of charge that they can hold. And while they may be suitable for cars, they're not yet at place where they're viable for larger trucks, ships, and planes. That's why another solution is needed, and most likely candidate of hydrogen fuel. Hydrogen itself can be produced by a range of methods such as natural gas, nuclear power, biomass, and even other renewable energies. And when it's used, the only byproduct is water. In the UK, a concept train has already been fitted with hydrogen cells, and it's undergoing tests. While aircraft manufacturers such as Airbus see this is a far more viable target in the near future than full electrification, and car companies too are looking at how it can be used. The technology is approaching the stage where it's possible across a range of applications, and it's only a matter of time until it's commonplace. Satellite constellations. The cost of launching satellites into orbit reduces, and with the improvement in component design and the potential uses of space technology, a number of big tech companies are now exploring the feasibility of creating their own satellite constellations. The idea of a network of satellites to perform a role isn't exactly new. After all, there are already 6 different navigational satellite constellations, like GPS, and a number of one-way and two-way communication satellite constellations. But these have traditionally only used a few dozen nodes to operate. Recently, SpaceX has been creating a constellation that its own called Starlink, which will then, it's completed, provide internet access across most of the planet. Amazingly, this involves positioning as many as 12,000 in orbit to give optimal coverage, and while the company may be paving the way, it's not the only organization looking like doing this. Boeing, OneWeb, and Amazon are also looking to develop their own constellations to provide internet access, and this is just scratching the space and surface of what they can be used for. If you look up when it's dark, you might just be able to see some of these satellites already, and if progress continues and current rate, the night sky may soon be full of them. GPT-3. Tech companies around the world are in a race to develop the full first artificial intelligence. But there are steps along the way that arguably are going to be far the most impactful in technology around us and how we live our lives. One of these concepts is the idea of deep learning, whereby computer algorithms can analyze past behavior and automatically find solutions to improve performance. One of the most interesting forms of this is called GPT-3, developed by OpenAI. It's the third generation of language prediction model, and the the idea is based on learning by itself. It's able to write text in the same way as a human does. It's one of the most difficult types of human imitation, and this latest attempt is almost unbelievable. Based on the initial studies, it's virtually impossible to differentiate between something written by GPT-3 or by an actual person. And companies like Microsoft have already begun to incorporate it into their products. Described recently are one of being of the most interesting and important AI systems ever produced. GPT-3 will further blur the lines of reality, and you may well find yourself reading news articles or even novels that haven't had any human involvement whatsoever. Connected homes. Throughout history, inventions have helped us save time on basic tasks, so we can dedicate ourselves to more complicated ones, and this progression is continuing into the 21st century. While the concepts of connected home isn't in itself a new one, the increasing presence of the Internet of Things and technological advancements means that it's going to become far more commonplace, reliable, and functional in the coming years. In 2013, the market in the US alone was worth almost $6 billion, and right now it's estimated that 37% of households in the US have a smart device in their home. Right now, these are usually in the form of doorbells, heating, light bulbs, speakers, and voice-activated assistants. But there are so many different ways technology can be incorporated that things will look very different in a few years. From connected fridges to power sockets, bathroom appliances, and even furniture, virtually everything that's electrically operated could potentially have a chip installed that'll make it operate from a smart device or simply by your voice. Furthermore, with so much of this being automated, our homes will take care of themselves and allow us to focus more on our interests and our families. Lithium Metal Battery. There's a focus right now on moving away from energy that produces emissions, and one of the best way to do this is converting everything we use to run on electricity. As long as electricity comes from green sources, major strides have been made in the past couple of decades. But one of the biggest limiting factors is that capability of batteries. Currently, the most reliable and most effective design that's used is a lithium-ion battery, but these have limits with how much they can charge and how quickly this can be alone, as well as some concerns about their safety if they're damaged. A company called QuantumScape is, however, developing an alternative which, instead of having liquid parts like lithium-ion battery, is solid, known as lithium metal batteries. That results from the company's early tests have suggested these could eventually increase the range of an electric vehicle by as much as 80% and can be recharged in just a fraction of the time too. Right now, the prototypes are too late to be fitted to cars, but they're expected to become much smaller in the coming years. So much so that QuantumScape has already signed an agreement with VW to start selling electronic vehicles with the new batteries from 2025. 3D printing. 3D printing has had a varied history since it first started being used in the 1980s, and even until recently, it's only been useful for very specific tasks. Essentially, feeding liquefied material into a chamber by applying layer upon layer, being able to create a 3D object. It's a technique that's mostly been known for creating small plastic objects or replacement components for certain devices. As our outstanding understanding and materials has improved, though, 3D printers are increasingly being able to make objects out of different substances and becoming seen as potentially the future of manufacturing. From clothing and food to medical devices and the ability to rapidly prototype new designs, the possibilities are endless, but perhaps the most exciting is how it'll change large projects. There's already a number of buildings around the world and have been built from 3D printed parts, and this is going to become even more common. Instead of needing to ship all the different types of bricks and other parts needed to build a house, all that's needed is a simply of the basic material and the printer, and everything can be manufactured on site. It'll reduce transport needs, wastages, and increase efficiently, and could mean new homes can be built at a fraction of the time they currently take. Blockchain. There are two main reactions when people hear blockchain. Either they start telling you about the best new cryptocurrencies to invest in, or they switch off from boredom. The fact is, though, that while blockchain technology does underpin the operations of these new decentralized currencies, this is just the beginning of how useful and integrated to our lives that it will become. Put simply, a blockchain is a list of information that's linked together by cryptographic techniques, and once a block has been added, it can't be changed and acts a permanent record. To begin with, this was used to prove who owns a particular coin, currency, or more recently, pieces of digital art. But there are a number of companies exploring how much wider the uses are. There are already examples of how blockchain is being used to enable energy trading and various other transactions, but perhaps the most important use is that it can track the history of individual products. The food industry can benefit hugely from this by being able to prove exactly where and when ingredients were harvested and cooked, and brands will be able to always use the blockchain to prove whether an item is an original or a forgery. Fighting fire with sound. With our changing climate, wildfires are becoming more common across the planet, and they're becoming even more difficult to control. As an example, in California alone, 5 times the area is burning each year now compared to what happened in the 1970s. This is only expected to increase. Traditionally, the way to extinguish or at least limit the spread of fire would be to use huge quantities of water or farm. But with water shortages happening too, and the reluctance of drops to chemicals onto the land, an alternative can come soon enough. Luckily, a solution was first revealed in 2015 and has continued in development to the point where it'll soon be deployed on a large scale. First designed to put out small fires in kitchens, the acoustic extinguisher uses sound waves to push oxygen away from the source of a fire and spread it over the wider area. This cuts off the fuel of the fire, and if maintained for long enough, will simply cause it to fizzle out. There have been attempts to do this before, but now that the optimal frequencies and techniques have been figured out, it's very likely that this will become one of the main methods of fire control in the coming decades. Quantum computing. We all rely on classical computers for everyday tasks, but there's a point at which no matter how many powerful chips you connect together, they become impractical to perform highly complicated roles. Computer scientists from around the world have since the 1980s been pursuing the next big development, the creation of quantum computers, and they're now closer than ever. Essentially, a quantum computer is different to a classical one in the way that it stores and handles information. In a classical computer, you'll be able to familiarize with bits that can either be 1 or a 0. But in a quantum computer, they use qubits, which can be in a 1 or 0 quantum state or a superposition of both. What this means is that quantum computer is able to solve any problem a classical one can, vice versa. And in some situations, will by far be efficient in doing so. One of more interesting things about quantum computers is that they won't actually always be the better choice, and researchers are still exploring the situations when they will offer an advantage. But the biggest hurdle right now is building one that's large and stable enough to see how well it can perform.